Iceberg support in Fluss is almost here. And while it hasn't been released yet, it's coming soon, I got my hands on the first demo that I run locally, check that it works, and I am recording a video about. If you are new to Fluss, I'll try to describe it very briefly. It's a stream storage solution, so same category as Kafka and Pulsar. However, it's built for real-time analytics. It uses columnar format for storage, and it addresses the problems of analytics by two key differentiating features. First of all, it allows you to do column skipping, so read only the specific columns that you are interested in, which wouldn't be very impactful in operational systems, but in analytics you might quite often see datasets 50 columns wide or even larger. And being able to directly read only the columns that you are interested in, it provides huge efficiency gains. Another key feature is predicate pushdown, which you might recognize from Parquet, where every batch that is stored in columnar format, every column has summaries, which allows you, if you are running analytical queries, where you are interested only in a subset of data fulfilling certain criteria, you are able to read only the specific rows you are interested in. It is deployed as a standalone cluster, and in this demo today I will show you more or less how it works with Iceberg. And functionally it's not a revolution. What you will see you could have done previously with Pymon, but Pymon is not in the same category regarding adoption and ecosystem size as Iceberg. So I think that this will be very impactful because for both sides. For Fluss, it will be able to integrate and access the huge Iceberg ecosystem, and for data lake houses built on Iceberg, now you will be able to slap on this hot layer only for the specific use cases that actually benefit from this sub-second latency, and use Flink, the most mature and widely adopted stream processing system. So what you will see on the demo is on a very high level a Flink job that is reading from a Fluss table and it's writing to a Fluss table, and there is a tiering job that is moving data periodically in the demo every 30 seconds. From Fluss to Iceberg. So what Iceberg sees is every 30 seconds it gets a new write of all of the data that was collected in Fluss, but Fluss is able to serve this data in real time. And there is a mock data source that's writing periodically to this source Fluss table, so that the actual job is doing actual aggregations. To show you that the data really is in these two places, we will be querying Fluss directly from Flink in real time. And we also will be using Trino to query Iceberg, and I'm using Metabase on top of Trino just to provide a UI so that it looks prettier on the video. So this is the repository. You can check it out yourself, and there is a straightforward instruction, but what you will need to do is you will need to check out and build Fluss locally, because again this is not released yet. So I did that, so I'll just be running the demo, and I'll start with running Docker Compose. I connect to the SQL client, and I will be running all of the instructions one after another. First I create the Fluss catalog, then I start using it, and then I create the tables that read from the source. The demo creates and tables populated in a not very straightforward manner from using Faker, so the fake data is being generated as we go. Then we define the destination tables, and then we define the Flink jobs. This is the one that we'll be querying from. So let's go to the Flink UI and see that everything's running. No error so far. Cool. We have 3 Flink jobs running. One of this is the lake tiering service. The other 2 are inserts. Yeah, and then we create the aggregation job. That's writing to a table that we will be querying. We'll check it again. Yeah, we have 4 queries now. Great. Now that all of our jobs are running, I will be querying them from both Fluss and using Trino. And I have locally set up Metabase to do it, which connects through Trino. I have my values sorted by revenue to make it look better. And in Flink, I'll be querying for the current state of Jordan, right? So right now in Fluss we have 314, and it's a streaming query, so it's being updated in real time. And here you can see that this is the current timestamp of the last flash right now. Yeah, and that now it's 319 because it's being moved to Iceberg every 30 seconds. This is part of the SQL definition. But at the same time, our streaming query in Fluss it's reading this with like second level latency. And I'm querying only for a specific country here because I didn't find a way to order this in the streaming query. We can only find Jordan, right? And now it clicked, now it got flashed. So 30 seconds later, every 30 seconds we see this data in Iceberg. What's cool about Fluss is that it allows you to either define that Fluss maintains the table, so it's responsible for both vacuuming the snapshots you are not interested in and in compacting the small files, because without it you would have a lot of small files. But it can also work with an external table maintenance if you are running on Databricks or Dremio, anything that does the maintenance for you. You can decide how the maintenance happens. And yeah, and here it is. The data in Iceberg has 30 seconds freshness. Data in Fluss has second level freshness, and it just works. It's very early for Fluss, so this is, as far as I know, the first recorded demo of this integration. Again, this hasn't been released yet. But yeah, you can, if you want to use Flink with your existing Iceberg-based data lakehouse, then Fluss is probably the best technology to use as a hot layer in these specific use cases that actually require low latency. Yeah, so the integration is here. I'm really looking forward to more developments from Fluss. I've been writing and recording about this project for a while, and I'm really excited about it. And I'm really looking forward to seeing this working with Iceberg. The release, as far as I know, is expected to happen roughly 2 weeks from now. I'm not the author of the code. I only slapped the Iceberg UI on top of it so that it looked good on the demo. The author is Yuxia. I hope I'm not butchering your name. If you made it this far, thanks a lot for watching. If you don't want to miss the next video, click the subscribe button. Yeah, and I'll see you in the next one.